Cats land on their feet. Ever wondered why? Say you're on top of a building and you suddenly have this urge to throw things off it. Well, you could maybe throw a jug, a phone, a table, Sasuke maybe, or a soy burger because it's so bad, or maybe even Shaktiman, but like, don't do that. And while you're on this throwing spree, you see this lame cat walking on the terrace, and you're like, well, why not? So you throw it off the building. But then what happens? Does it fall and break bones and die? Does it enter another dimension and live there safely? Or maybe, does it survive? Turns out, even though Sasuke might break bones and cry for Sakura to save him, the cat survives. It actually does, believe it or not. It doesn't matter if, like, how tall the building is, the cat survives. Wait, wait. So the cat survived? Hmm, interesting. Yep, it did. But then, how do you think he did that? Well, did he turn into a flying chicken? Or was it all along a super cat with a super high IQ who just fooled us and will take over the world ultimately? Or was there some really cool physics behind it all? Well, meet our cooperative, friendly cat volunteer, a kid. And let's take a kid and throw a kid off the building and see what happens. But before going any further, let's sort of look at some concepts like angular momentum. Well, what is angular momentum? Turns out, with every moving body, you can associate this quantity, which is just the mass of the body times the rate at which it's spinning. And enter Newton. Well, one of the really cool things that we can actually derive from Newton's laws are that angular momentum is actually conserved for a quantity upon which there are no external forces acting. Now, remember that if we once we throw the cat off the building and we neglect the air resistance, there's not actually any other external force acting upon the body as such. But at this point, you might ask, what does any of this have to do with a falling cat? I mean, obviously, a falling cat can't start rotating, right? Like, how would it turn over and like rotate without touching anything? There's nothing in air. So, how is it doing any of this? Or how is any of this related? Aha! Well, turns out that a cat actually manages to change its orientation without actually changing its angular momentum at any point of time mid air. Let's see how this happens. But before trying to analyze what the cat does mid-air, let's try to convince ourselves that the angular momentum initially and finally are in fact conserved, i.e., zero. Well, initially when you're throwing the cat upside down, since it's not spinning at all and it's at rest, I can say that L is equals to zero because there is no rate of spinning, remember? And finally, again, once the cat is falling straight up, again notice that there's no sort of spinning in the cat at all. And then obviously, again, L is equals to zero. But then comes the question, what is it doing midair? So remember that at all times, L, which is a product of mass times the rate of spin, must always be zero. Let's see how the cat does this. Initially, it pulls its front legs towards its body and spreads out its back legs. Then it twists the front half quickly one way while twisting its back half slowly the other way. Notice that doing this will ensure that the angular momentum, that is the product, actually turns out to be equal. And since the twisting is in opposite directions, the total angular momentum turns out to be zero. Then, after some time, it spreads out its front legs and pulls its back legs towards its body. Now, it turns its back half quickly to align with the front half, while the front half turns slowly backward. Again, note that since the product will turn out to be equal and the spins are in the opposite direction, the total angular momentum again becomes zero. And a very interesting key element in all of this is played by the tail, because any sort of additional let's say, deviation that could be And interestingly, a very key element in this entire process is played by the tail of the cat, because it usually assists the process by providing a usual reservoir of spare angular momentum. Here is a picture of an actual cat being thrown off some height. Notice that you can actually see the opposite twisting happening in the cat's body. Thus, by moving in opposite direction, a cat ensures that at all times its angular momentum L is in fact equal to zero and thus safely lands on its feet. Thank you for watching the video, and for more such quirky, cute, retarded outbursts of physics, please do check out the website Fatal Physics. The link is given in the description below. Till then, namaste and keep sciencing.